Welcome, everyone. We're so excited to have you today. We're going to be talking about claim evidence reasoning writing. And as a English language arts and science and social studies and every subject area during COVID teacher, I really had to kind of beef this up in my career. So it's kind of a passion of mine. And I will tell you that my English language arts teacher that I taught with my last few years, he was like, I do not have to teach argument because you do such a good job at it. He's like, I literally just like do a pre-assessment and most kids are like good to go. So if you do a good job with this, your language arts colleagues will thank you for sure. All right, so just some housekeeping things. We'll use the chat and the Q&A, and Amanda, my co-host, will kind of help respond to those questions that you have, and then if she'll throw them out to me if we need to, if she thinks it'll benefit everyone. Go ahead and make sure that when you're chatting that you're chatting with everyone so that we can all see your questions. If you have it, somebody else probably does too. And then if you need the closed captioning, go ahead and turn that on. These are things that Brian went over earlier. All right, so I want to start, and I have to kind of jump out of here. I want to start with what grade you teach. So if you can, this is going to kind of help me to determine where I want to spend the bulk of my time today. So we'll go ahead and have you tell us what grade level. If you could scan that Mentimeter code and then let us know what grade you teach, that would be great. Again, I can see. All right, I have. All right, we've got, it looks like, oh, we've even got first grade in there. We've got upper elementary. We've got middle school. We've got a little bit of everything. Do I have any kindergarten teachers? I'm looking to see if I've got kindergarten, second grade, first grade, third grade. That's great. All right. So we've got quite a, we have got a kindergarten too. So we've got a little bit of everything, which is great. I've prepared for us. We're going to look at a kindergarten, a fourth and an eighth grade lesson a little bit. And I'm going to give you some tips and tricks and things that have worked for me and also have you share some things too. So we'll jump right back in to our slideshow here. All right, so my name is Dr. Kristen Topolinski. I'm a TCI training specialist. I am from Michigan, so I have been in public education for over 27 years, taught science all those years, and absolutely love science, and also taught all subjects. Like I said, during COVID, I was virtual, which is always interesting. So lots of experiences. All right, so what we'll be covering today, we're going to define claim, evidence, and reasoning. We're going to look at that progression of claim, evidence, reasoning, writing. I'm going to show you some suggested ideas and some lessons right from TCI. And I've created, done some research and created some documents that I think will be helpful. And I'm going to have a whole folder that Amanda will share in that resources page later on for you to look at. And then I've got some K-5 suggestions, some templates, and then we are also going to take a look at the 6-8 TCI toolkit for CER. And really that you could even, there's components of it that you might even take down to, you know, like third grade or fourth grade. Certainly you could do, it is made for 6-8, but you'll have access to it so that you can look at it as well and see if you could adjust it for your grade level. All right, so claim, right? The claim is the statement that helps to build an argument in its attempt to convince people of what you think with your scientific reasoning. So the evidence is numerical or observational data that supports the claim. And if you're teaching middle school, you might even get into quantitative and qualitative data and talk about it in that sense as well. And then the reasoning shows how the evidence is connected to the claim. and it uses some type of logic or scientific concept to help with that reasoning. So those are the three key pieces here. So when we look at the NGSS, we see that a big part of that is to have the standards connect, right? We don't want subject areas to be silos. We want to interconnect them. And that is important when we're building communication. So we want scientists to be able to communicate with other disciplines as well as other scientists around the world. And in order to do that, they have to be proficient readers and writers of science material. So the key to claim evidence reasoning is really we're communicating out some of the things that we've found as we go through these investigations. So when we look at the progression in the standards, claim is introduced in 5th grade, evidence is in 3rd grade, reasons actually start in kindergarten, but when we get to reasoning, it's not introduced till 6th grade. So 6th grade is really where everything comes together. And we really want to make sure that students then at that point moving forward really have a solid understanding of claim evidence reasoning writing, because they're going to be doing it throughout their career. And again, it's also called an argument, which that would be more of like a literary essay where they're arguing something maybe about a character or something else, when we get into like, you know, that holistic piece. But certainly these are skills that are transferable. Like I said, your English language arts teachers will love you when you, if you're in a grade level where you're not teaching English language arts, because certainly this will give them the skills they need. All right. Any questions so far about anything that I have presented? Okay.
Nothing in the chat or Q&A.
Yeah. Is there one in the Q&A? I am
Oh,
not.
no,
Okay.
not yet. Yeah.
Okay. Perfect. All right. So one way that I like to introduce CER is that very first week of school when we're all coming back, and I pose a question, what do you know about your teacher? And I have them just have a piece of notebook paper, or if they have a science notebook where they write in. I have things scattered throughout my classroom. I have it decorated with things that I, collect, or pictures of my family, or favorite foods or snacks. I love to bake and cook, so I will have like maybe a homemade muffin or cookies or something so that they can see some of the things that I like. So, and I just kind of have those spread around my room. And what I do is I give the students 5 minutes. I set a timer. I let them kind of circulate. You can have them do it in pairs. You can have them do it on their own. You could have them do it in groups, however you want to do that. And then after the 5 minutes of them collecting that evidence, I usually present several statements, and I purposely do some that are true and some that are false. And then I ask them to determine which are supported by the evidence in the room. So, and my students call me Dr. Top. I shortened it. So I have the first statement, Dr. Top has 2 children. Okay, that is a true statement. They would find evidence throughout the classroom of photos of children displayed in there. They would see my son and my daughter. Dr. Top likes to bake. Yes, I would have a homemade baked good. I might have images of things that I've created. I've done wedding cakes and especially decorated cookies, all kinds of things. And so they would see that evidence. And then the last one is that I'm an avid golfer. That is false. And they wouldn't see any kind of equipment or any pictures of me golfing. So that one would be false. So when I give them the statements, then I debrief afterwards, asking them to determine, again, are those true or false? And then what evidence did they support? So here's an example of a response that a student might have. Yes, Dr. Top has 2 children. In all of the pictures of her family, you can see that there's her husband, her son, and her daughter. Therefore, she must have 2 children. So you're kind of helping them in a way that's kind of fun and interactive. They get to know you a little bit. And then you get to know them. So that's one way that I like to introduce claim evidence reasoning. Are there other ideas that people have? Throw those in the chat if you have some ideas of other ways that you have introduced claim evidence reasoning in your classroom. All right, I'm not seeing any other ideas. That's okay. All right, so we'll jump in and go on. If you have some, you can certainly share them. So when I did research and when I was learning more about claim evidence reasoning writing, when it came in with the next generation science standards, there were three books that I used. And what I did was I took a picture or copied the cover of each book, and that will be in the folder so that you know kind of where I'm taking my information from. Um, and so these are some of the scaffolding pieces that I find very helpful for my students. So the first thing that I always want to remember is that they can do more than we think they can. So setting a high bar for them and a high expectation and really asking them to hit that expectation is one of the key components when you're doing claim evidence reasoning writing. You've got to expect them to do more. And that's really key. And then the second one is using those word walls for important scientific vocabulary. It might even be like content vocabulary versus like, so it's actually what's in that lesson, but also like just in general in science, like investigation or explain, those key words that you might use that students need to understand. Having that vocabulary word wall is going to be key. And you might have some words that stay up all year because those are ones that you're using all the time. And maybe you might have some that are just dedicated just to that unit or that lesson. And then one of the other things that I like to do either at the beginning of class, like the following day, or at the end of class as like a closure, is review that unit or lesson question and have students talk about what they learned that day or maybe what they learned the day before, so that you're constantly reminding of what is it that we did, what did we learn so far? Because when you think about the phenomenon in the next generation science standards, you're having to answer lots of questions to really understand what's causing that phenomenon to happen. So the more you can review, the more we know that the brain will latch on to that and really understand it better. Building charts and graphs together. Certainly I had them keep like a notebook. If I was going to draw one, and then I would have like a big poster chart in my room. And then I would make sure that they had it accurately done in their book, or we had an accurate one in the classroom so that they could refer back to it if they needed to. So certainly doing that helps to build that accuracy. It also helps them to see, if there's trends or patterns in the data that you collected from the investigation. And then writing out all the collected evidence, making sure that they have that evidence somewhere in their scientific notebook. They get also like reminding them if they're doing it online, they can go back to it online too. And then really giving them time to process and talk through their answers. So when we think about learning, we know it's such a social concept, right? We're trying to create meaning through socialization. And so even having them talk through what is your claim, and the one student says it to the other student says it back. Even just that before they get to the physical writing, the more that they can talk through, the better it'll be. That's huge too, especially if you have multilingual learners in your classroom, which I always had a cluster. So that is key, right? They have to be able to talk through what they're thinking, or even if they can't come up with all the words yet in English language, hearing it from their peer is a big uh, plus for them, that they will pick up on language faster. The other thing is at the beginning of the year, I always model that entire process. I make sure that they understand from beginning to end what a claim evidence reasoning writing looks like. I am going to show you that I color code each part so that I can quickly look at a student's work and say, okay, you have the claim, you have the evidence, you have the reasoning. Then I can go back and really read it over to make sure that they correctly identified each part. But it's a quick way for me to visually say, okay, I think you've got all three parts. The other thing, especially with younger students using frames, I think because my evidence is the data shows, as you get into adding more pieces of evidence or more reasonings, you might have also in addition. So that's why I think, so there's having those writing frames can also be a huge benefit for your students. What questions do you have about scaffolding, or does anybody have any other ideas about scaffolding that they think would be helpful for the group? Oh yeah, video clips. Okay. Alien commercials. Oh yeah, those are some other ideas of ways to introduce it. Okay, good. All right. Anything else scaffolding wise that you can think of? All right. Okay. I do actually have a video if we have time at the end. I've got another commercial video that is funny that students of all ages will appreciate. So if we have time, I'll share that one with you too. Okay. So again, any additional ideas? We're gonna go live now, and I'll start with the kindergarten piece first, and then we'll Kelly was asking if there's graphic organizers. There are not graphic organizers within TCI that I know of, but what I'm going to give to you in the folder is an example of one that's a freebie from Teacher Pay Teacher. And it's got lots of different good ideas in it. The only one that we have that we use, and it's not necessarily, it's very linear. So it's built with questions and answers, and there's like lines for them. And I will also give you that one. That's the 6-8 CER toolkit. But I promise I have a resource for you. And there's tons of free ones in Teacher Pay Teacher. But this one I liked because it had so many different options, and I'll share that with you later. But let's go ahead and jump into the kindergarten lesson. Oops, hang on. So let me jump in, and I believe, yeah, put it here. Okay, so I intentionally picked 3 different lessons that highlight the spiral that TCI uses. So we're going to be looking at motion, and we're going to be looking at pushes and pulls. And then in 4th grade, we're going to be looking at energy and how energy is related to motion. And then we're going to get into kinetic and potential energy in 8th grade. So I wanted you to see that TCI is built on a spiral concept so that students start with small pieces and we keep adding the pieces throughout. So we're going to take a look at these. But really the key in each of these lessons is that it starts the same. You're going to observe that phenomenon first. And it's very helpful. So this first one is just this is at kindergarten again. Have you ever kicked a ball? How far did it go? Every student has probably had that experience. You certainly could have a soccer ball in the classroom. And then the ball starts moving when you kick it. Like that's the phenomenon. And I think for especially lower L students, like for them to understand that when I say phenomenon, it's not some big great thing. It's just something that happens every day. So every day, if you go out onto a playground in the United States, you're going to see a student kicking a ball, or you're going to see a student rolling a ball, or, certainly those are things that happen every day across the country. All right. So then there's always like a little video clip. So you can watch the video. The student is kicking the video or kicking the ball in the video. There you go. And throughout this, they're going to be exploring pushes and pulls. So there's other videos too in here. You can watch.
I want to move something. You want it to go fast. What can you do to make it move? You push on the ground. Your scooter starts moving. Push harder, you go faster.
You can kind of get the gist of that. They're going to be looking at pushes and pulls in this lesson. And they're going to be looking at a wagon. Then they're going to have this investigation where there's 2 different boxes. One of the boxes is completely empty. The other one has these little pebbles or stones in it, and they're going to push and pull. They're going to realize that they have to push harder on the box that is full, and they have to push, or they don't have to push as much with the empty box. So those are the things that they're going to come up with. They just have 2 vocabulary words here, push and pull. They're going to identify which one of these things is a push, which one is a pull. And then you kind of wrap up that science concept. And they even get to identify, where they think they are on the scale, to not knowing to being an expert at it. They have some notes and some reading that they'll do. And then we're going to get into show what you know. This is a little sorting activity they do. And then the last one is making sense of the phenomenon. This is where they have to come up with their claim, evidence, reasoning to answer the question, what would you have to do to make a ball go farther? So they have to think about these two questions. How will a ball move if you kick it hard? How will it move if you pull it softly? Okay, so if you pull something softly versus kicking it hard, what happens? And then they're going to answer that. They're going to make a claim, have evidence and reasoning. And then go ahead and share with you. So using all the information that they had, I put the question here, you can see what I always have them highlight the claim in green. So to make the ball go farther, I would push or kick the ball harder. Okay, so that's the claim they're making. The evidence is when a person moves their foot back 6 inches and then kicks the ball, it moves. When a person moves their foot back 12 inches and kicks the ball, it moves farther. So they learned that, pulling it back further, swinging it more, that's going to make the ball go further. And then when I'm going to go ahead and go on to the next part here. It is not, let me see if I can move this. Sorry about that, guys. My bar is in the way. There we go. So when a person kicks the ball, it will move with more force and it travels further. Okay, so now we're going to jump into the 4th grade example. And in the 4th grade, this one, again, the phenomenon is similar because we're looking at, well, we first start by thinking about cannonball. And I don't know if it depends probably on where you live in the country, if everybody has done a cannonball into a pool before, but what do you have to do to make a big splash? So it makes you think about that. And the actual phenomenon is when you kick a ball into a soccer net. So the net moves more if it's coming at a fast speed, or if the ball weighs more, right? If the mass of the ball is more, the net is going to move more. So they're going to try it. They're going to roll a ball slowly. You can just roll it against the wall in the classroom, then roll it more quickly, see what happens. They're going to see kind of how it bounces back and that it might bounce even further back if you're rolling it really hard. They also are thinking about the sound that it makes when it hits the wall or bounces on the ground. They're going to be doing that in the investigation. So go ahead and show you. There's a quick little video just to show you what the actual phenomenon is. You can see that the net is moving there when the ball hits it. Again, the great thing about TCI is it shows you how to set all these investigations up. You're going to have this board and you're going to mark it off. Or I was even thinking you could even just tape a ruler right to the board. And you're going to be rolling a ball from different parts of the actual board. So they're going to roll it. You can see here, they can set whatever number they're going to do the same each time. And it is set at a low angle. So they're going to roll the ball from, let's say, 25 centimeters. And this is going to be at like 15 degrees, the angle. Then they're going to roll it from a higher angle. Let's say it's going to be a 45-degree angle from 15 centimeters again. And they're going to kind of look to see how far did it go and how fast did it go. So once they release the ball, how long did it take for it to get to the 1 meter mark? Or how long did it take to get to the 2 meter mark? Or did it even make it to the 2 meter mark at all? They're going to be collecting all that data to really understand what happens when you have the ball. They're going to be thinking about the energy that's with that ball, the transfer, what energy is conserved. And then they're going to kind of wrap up the science concepts there in that section. All right. They're going to rate what they learned. And then they get into the reading. One of the other things about claim evidence reasoning too that you want to keep in mind is that their evidence could come from the reading. It could also come from a video. So when we say text, we are thinking about video evidence as well as reading evidence. So they may be taking it from places that they've read or things that you've shown them videos on certain things. So that's also something to keep in mind that's acceptable. As long as they can tell you where they found it, then you're good. Okay, so then once you get to the end, you've gone through all the different investigations for this. They're going to come back to that question. What might be different if the ball was kicked more slowly? So if you're kicking the ball more slowly, what's happening to that net? And there you have to think about what happens, what the impact is, what the energy is in that ball. So again, this is from the 4th grade unit. And the claim is a ball kicked more slowly has less energy than a fast kick ball, and it would not move as much or make the net move as far. So that's what they're going to find if they're kicking it with less energy. That's what's going to happen. Then the evidence is that a slow moving ball makes the net move only a little, like the ball moving from that low angle, right? If you rolled it from 15 centimeters from a low angle, it's gonna move more slowly than a fast moving ball, which will make the net move more. And releasing that ball from a higher angle will also make it move faster. It'll get to that 1 meter mark, 2 meter mark much faster. So the reasoning then is when the ball is dropped from a high angle, it rolls faster and farther. Likewise, hitting a ball with more force makes it travel further and hits an object with greater impact. So certainly they're able to come up with all of these things as they think through these parts of the lesson. Okay, and so then we bring it full circle. We get into kinetic and potential energy in our science curriculum, and we're getting into the phenomenon. So this one has to do with a wrecking ball. So I'm going to go ahead and jump a couple screens so that you can see. The phenomenon is that a wrecking ball causes more damage when it's when the actual wrecking ball is bigger, right? The mass of the wrecking ball is bigger, or it's swung from further away. So let's go ahead and just take a look at this quick video here. Sure. And in this one, they're not showing different ways that it's swung. So it's really just kind of making them still think about what happens. So in the first part, they're going to watch the ball fall, and they're going to talk about potential and kinetic energy as the ball moves. And they're going to think about when that kinetic energy is the most. And they're dropping it onto the table. You could often drop it on the floor too, whatever works for you. This one, they're gonna listen to the sound it makes when the first impact versus those additional subsequent smaller impacts. So this is it's interesting for them to think about how energy makes sound too. And it's only 1 second, so I would play it twice. Okay. So you can see that when it hits originally, right, there's much more energy that's making a louder sound as opposed to the subsequent droppings of the ball. All right. Why is it? There we go. Okay, so in part 2, they're going to drop the ball now from a higher height, and they're going to do the same thing that they did in the first part. And they're going to also think about the mass. So if we had a smaller ball and then a bigger ball, a much greater mass, then what is the difference going to be? And you can think about the difference in sound. You can think about the difference in speed, all of those components. They're going to drop 2 different balls from the same height, but with different masses, and see what happens. They're going to think again a little bit about what happens in a vacuum and what happens, different ways that we're pushing and pulling, like on the swing, rocks dropping into water. We're going to think about all of these things. We're also going to think about a bike going through a puddle, a smaller puddle versus a bigger puddle, and what the difference is. I'll just play these really quick. Okay, so that one makes a little bit of wave, but then when you look at this one, you can see it's a much higher. The water is dispersed much more and it goes much higher. So they're going to make predictions again about if we were to take the mass of the wrecking ball and double it, what would happen? And then if we were to take the speed of the wrecking ball and double it, what would happen? So they're thinking through you know, what happens as you increase mass and you increase speed. And then they're going to do some reading, and we're going to be reading about bowling balls. And then they're going to get into making their own wrecking ball. So in this one, they're going to create, and hang on just a second. All right. So they're going to create a pendulum, and here's the picture of it. I was trying to find that. And they use a pencil and a string and some tape, and they create just out of little cubes, and they're going to actually create their own wrecking ball and test that. What happens if you double the mass? What happens if you change the speed? Obviously, it's where you're pulling it back to and then dropping it. And they're investigating all of these things throughout this this lesson. Do more reading. And then the last one is where they get into graphing the kinetic energy and the relationships. So they're looking at the mass of the bowling ball and the kinetic energy that it has. And they're trying to find the ratio of mass to kinetic energy. And then that one was at 4 meters per second. They're then going to look at 6 meters per second and what happens. And so I'm going to show you here. Here's both the 4 meters and the 6 meters, the data that was there, and they're looking for that proportional relationship. And then as they go in, they find that it is directly connected, kinetic energy and the mass of the bowling ball. And again, you can watch these videos. This is just showing some bowling. If they're not experienced with it, it's helpful for them. And then we're going to go ahead and look at speed again, speed and kinetic energy. And this one is a little bit longer, but it also shows the wrecking ball hitting building that they're trying to tear down. So you kind of show them that and look at those things. So as you get going, they're going to see that there is definitely a relationship. There is an exponential relationship. There is a direct correlation, and that they find exactly what is happening. Okay. So we finish up, we wrap up, then we get into making sense. What you will find in the middle school lessons is that you have a hint, and the hint is to help students think of the questions that we had to answer in order to explain that phenomenon. And again, the phenomenon is a wrecking ball causes more damage when it's bigger and swung from further away. So then you've got these 3 questions that help them think about what actually is causing that. Also, in the 6th through 8th grade, you'll see this claim evidence reasoning button. That will actually take you to that toolkit, which is, again, I've made a copy for you in the folder. So it's only available through your TCI subscription for 6 through 8, but I'm putting it in the folder so that if you want to bring it down to like a 3rd, 4th, 5th, you totally can use it for that as well. Okay, so let's go back now to the 8th grade. All right, again, I've color coded them so that you can see the claim evidence and reasoning pieces. So because this is a longer one, and obviously as we get into middle school, we're going to have a little more explanation. I would start with just one claim, one piece of evidence, one reasoning. And by the end of the year, my students were doing at least 3 pieces of evidence, at least 3 reasonings with their claim. And then I would have them do a conclusion. I added more things, obviously scaffolding it throughout the year. But so the question, you have to kind of put the phenomenon into a question because it's not a question in the 6th through 8th grade content. But why does a wrecking ball cause more damage when swung from a longer distance? And I just kind of broke it into one part of the question to make it easier to see. So the claim, a wrecking ball causes more damage when it's swung from a longer distance due to its greater amount of kinetic energy. So when we collected that evidence, when we looked at those graphs, we found that a bowling ball traveling at 4 meters per second has a mass to kinetic energy ratio of 8:1 versus a bowling ball traveling at 6 meters per second has a kinetic energy ratio of 18:1. So they're seeing that it's increasing. It's more than doubling, right? Because it went from 8:1 to now 18:1. So as we increase that speed, we've got much more kinetic energy happening. So then the reasoning is that a bowling ball moving at a faster speed has more kinetic energy when it hits the pins. Likewise, when a wrecking ball is swung from further away, it moves faster and it hits the wall with more force, causing greater damage, which is what you want, right? If you're using a wrecking ball, you're trying to take a building down. So they can then put these pieces together. But you can see, especially on like this fourth grade one or the kindergarten one, that when I'm having a student write this, when I'm having them, and I usually have them turn it into a paragraph, we typically will draft it in this part that we have right here, and then I have them turn it into a paragraph using those transition words, those connectors that I put in the scaffolding piece as well. So you can see that I can quickly go, okay, you have a claim, you have evidence, you have reasoning. Now, you do have to read it to make sure they have it right, but certainly you can quickly check to make sure, at least I know that they think they have all three parts, which is super helpful. All right, what questions or things might you have about anything I've shown so far? Just looking
Oh,
to
there
see.
was one question, Kristen.
Sure.
How can you use sentence frames while also giving students the opportunity to use their own words? Do you have any tips on that?
Yes, yep. And I will say that a lot of times with those sentence frames, I would have them like maybe on a sheet of paper ahead of time. And maybe I'm just giving them to my students that are developing readers and writers, or my students that are have an IEP. Certainly, and that helps them. And then like, because I would often also have like a gifted cluster in my classroom. Well, obviously I want them to be pushing themselves. So maybe for that kind of situation, I would give the sentence frames to those students who need them. And then maybe the other ones, I'd be challenging them like, the other students only have to have one piece of evidence. I want you to have two pieces of evidence and two reasoning. So you can certainly, crank up what they're doing. And also the other thing too, with maybe your more challenged students is you can also have them, maybe you want them to tell you where they found the evidence. You can add different pieces to rank, to increase the rigor of what you're having them do, if that helps. I'm just looking to see if there's other questions. Certainly small groups. Typically what I would do when I was teaching claim evidence reasoning is I would have them, when we're first starting out, we come up with the claim together. Everybody has the same claim. And then we would have every piece of evidence that we've collected from the whole lesson on a chart. And the students then go and look at that chart. They decide which pieces of evidence they want to use. Sometimes students will come up with more than what you have on your evidence chart. And maybe we didn't, we had a pretty thorough list, but we were missing some things. So certainly I have that in the room so that they can go back and use that as a reminder or helpful piece to help them think about the activities that we did and what evidence we collected. And I then, if students don't feel comfortable, I might pull a small group and say, okay, I'm going to work with you three, and I want you to start by just telling me one of the pieces of evidence that you feel confident, like you remember that from the activity, you are capable of, writing it out, and what you want to say about it. You can think about the reasoning of why that piece of evidence connects back to the claim. So certainly that is really key. That reasoning piece, remember, that doesn't come in till sixth grade. So you might even in kindergarten through fifth grade, you might just have them have reasons for why the ball will be different when it's kicked more slowly. So they might not get to that reasoning, the full reasoning, but you certainly can expose them to it. Or maybe you come up with that together as a class after they've got their claim and their evidence. You might do the reasoning pieces together. That's another option too. But certainly I would pull small groups, especially if they just were struggling to, come up with something to write, especially, and if you have reluctant writers, I would always pull those in a small group because I didn't want them to get behind everybody else. So, that's another thing that I would use in there. Okay, let me go back. Okay, so I want to jump into the folder, and Amanda's going to put this link in there for you. Okay, so in this folder, this is what it'll look like when you click on it. This is the free templates that I was telling you about, and this woman, Julia Cannon, I love her stuff. She's got a lot of great things. This was a freebie. You could totally get it for free from Teacher Pay Teacher. She has like a pre-writing template for claim evidence reasoning. This one or this one where it's just blank. I thought, gosh, with kindergarten, you could have them draw a picture in there. This one gets into, okay, here now there's 2 pieces of evidence and 2 reasonings. Then we get into 3 pieces of evidence and 3 reasonings. I just really thought that she scaffolded this well. And then if you have students that are more linear, maybe they want to just see it like this. You certainly could do that. This is just kind of like a template that you could use to help. And also it brings in that conclusion statement, because you always want to have them have a conclusion statement. And when I have them highlighted, the conclusion statement's always in red, right? Because that's your stopping place. So I would have them highlight it in red. This is a cool thing that I put together just for this presentation. And what it is it has all of the claim evidence reasoning questions per grade level. So if you're in kindergarten, here are all the questions that your students are going to answer. First grade, those are all the questions you're going to have. Second grade, third, fourth, and it goes on. Then when you get to 6th grade, I did this slightly different because, again, like I said, it looks different. So what I did was I included the 2 questions that go back to that phenomenon. What is it that they're going to have to answer in order to be able to explain that phenomenon? So I put the questions in. So you'll see in there in 6th, 7th, and 8th grade, the questions they have to understand in order to explain that phenomenon, because it's set up slightly different. But they're all there for you, so that you can. And the other thing too, when I'm teaching claim evidence reasoning, that I think about is I want to do at least 3, maybe 4 of these a year. And I really want to be intentional about making sure I have enough time to do them, because it's going to take you extra time, especially if you're doing some of those scaffolding strategies where you're having students talk it out, or you're making sure you have all of the evidence from all of the activities written somewhere where they can see it. So I usually was intentional about trying to schedule 1 per quarter, or if you're on trimesters, maybe 1 per trimester, however it is that you want to work things, but you want to really dedicate the time to do it. And so you've got to be thinking about that and thinking about your time frames. So that's another piece that I always think about. This was one I started to put one together myself, but I feel like she did such a better job than I did. So I just had two in there that I was thinking of. So certainly you don't have to use mine. I like hers better. Then the toolkit is in there. So that's in there. If again, it's available on TCI for 6th through 8th grade, but I really think you could use it at lower grade levels. It helps to identify like the definitions and gives you an example of all of that. Some of this might be a little challenging for 3rd graders, but there's some pieces you could use. And then those 3 books that I was talking about that I used, these 2, Writing in Science and Writing in Science in Action, are by, I have them actually here. Betsy Rupp Fullweiler, and she has a lot of great ideas. And she this one, Writing in Science and Action, actually has a video, so you can watch different components or things of it. And then I'm not sure if people are familiar with Doug Fisher, but he is like a guru, and I love him because he's still in the classroom and he does action research. So whenever you see something by him, you know that he's actually tried it in his classroom. And this one is called Reading and Writing in Science. And there's a whole chapter just on writing for science, and it's super helpful. So those are some pieces that are really helpful. And Doug, I would say his is more, you can see even from the images, his is more middle school, high school. So just something to keep in mind. I don't know how that got copied in there twice, but it's in there twice. Any questions about any of those resources?
Kristen, there was one
Yeah.
Q&A about explaining the difference between evidence and reasoning to
Okay.
5th graders specifically, but they
Yep, absolutely. Yeah, and I taught 5th grade, but only 1 year. So, but certainly even the beginning of the year for 6th graders, they don't always know the difference. So really making sure that you clarify And I can go back to that definition. Let me go back in my slide deck here for a second. Okay, wait a minute. It's not, there we go. Really spending a lot of time talking about that evidence is either going to be numerical, like it's actually a number that we found. And if they're having trouble with evidence, I would start by just picking ones that only have numbers. So if they're collecting data, like how far did the ball roll, like in that the fourth grade one where they roll the ball down the ramp, I would just start with, okay, the evidence for this is how far the ball rolled, and we just measured it. You can measure it. That's one way to really help them, because the reasoning is really connecting that data, that number, back to the claim. So that's how I started. I picked things that had numerical things versus observational things at first, and then they really understand that evidence, it will more than likely, most of it has a number, especially if it's a lot of quantitative things, like it could have a temperature, it could have a measurement, lots of different things. Like I did one with humidity, it might have a reading on the humidity detector. So certainly versus observational, where it might be something where you're observing a bird in a tree or something like that. So certainly that's a good place to start if they're really struggling with that piece. Other questions or things that you're wondering about in there?
Oh, there's one in the chat. Do you provide a model of a written CER paragraph?
Yes, I do. My district uses Canvas, and we also use Google Classroom. So I always had like the one that we would do together at the beginning of the year. I would leave it there, and they were allowed to go back and look at it. That way they could see the way I color coded it. And we would talk about, especially as you get into middle school, where you've got like 3 pieces of evidence and 3 reasonings. I would let them, if they were really struggling, I would make them do evidence, reasoning, evidence, reasoning, evidence, reasoning. But if they were capable of it, I would have them put all the evidence, and then they could put the reasoning afterwards. So it's going to depend how you want to do that. But I always gave them a model of both, of what it looks like in what I call a seesaw, which is a piece of evidence, then the reasoning, then a piece of evidence and the reasoning. And certainly that's scaffolded per grade level. So for, lower L, you're going to have just the claim, just the evidence, and just the reasoning. But certainly giving them an example. Models are huge when they're doing things like that. It's also helpful, like just with punctuation in general, then they can go back and look at it and see how you punctuated it, and how you set it up, and your transition words too. It's just good for them to have a model. And the other thing too is, once you have students do them, you could certainly have like a student model once you've tried it a couple times. So you can find some good examples of students. Other questions that you have? All right. Okay, so just a couple other things. We'll kind of wrap up here. We've only got a few more minutes. We're here to support you every step of the way. We want to make sure that you know that there's professional development right in your TCI account. There'll be a what's new coming up for the fall. Certainly the grading piece is new this year. If you haven't taken a look at that, there's a little orange button. Remember, those are the things for you that shows you what the new grading thing is going to look like. TCI has Facebook and Instagram. We love to see pictures and things that you're doing in your classroom, and share those great experiences that you're having with your kids. Again, the in-app, that's right in TCI. It's right underneath your programs. And you can click on it. I use it like a cookbook. I just jump to the section I need. I don't ever get worried about if it tells me it's going to take an hour and a half or 2 hours, because I can just jump to the part that I need. So think of it like that. All right. Was it helpful? What are you thinking about claim, evidence, reasoning, writing for this upcoming school year? You can throw in the chat 1, 2, 3, 4, 5, or 6. Good. I'm so glad it was helpful for you. All right. I'm gonna go ahead and, I wanted to show you, I've got one other, oh yeah. If you share, on Instagram, if you share or Facebook, you can win $100 gift card as well to use in your classroom or wherever you want. And then also, you can get a TCI llama. So very cute, very fun. But I wanted to show you that other example. I had one more example. I think we have enough time. We have 5 more minutes, of this one. Okay. So this is another way that I've introduced it before, and it is fun. The kids watch this commercial, and in the commercial, see, hang on. So let me go back here. Okay, so another cute way to introduce claim evidence reasoning, watch a commercial. I think somebody else put it in there. So what happened to the cat? The dog killed or took the cat. You can you can interpret that by your grade level, how you want to word that. Evidence, the dog is seen bearing the cat's collar and tags. The missing cat sign. The dog tells the owner he didn't see anything. And then the reasoning is that dogs and cats are natural enemies and they don't get along. So that's another way that I've introduced it before, and it's just kind of fun. And you can bring in that commercialism a little bit too. But and kids like Doritos, right? All right, so the next period is going to be coming up. So those are the sessions. And I believe that Amanda will put in the chat the link so that you can get back out to the lobby. We still have a couple minutes left, but if you have any other questions, let me know. Oh yeah, she just put it in there. So it is in there. Yeah, perfect. All right. Well, thank you so much for coming. And then I don't know, do they share out? Good question. Amanda, you would probably know this. Do they share out our slide decks? So that, 'cause somebody wanted to know the video.
Oh, that's good. I'm not sure about
Okay.
the slide decks. I just know we're sharing the recording.
Okay. Yep. Erin, I'm gonna go ahead and I can put that video into, I'll put the video into that folder so that when you go back to it, you can have it. Erin had asked that. So I can do that real quick in between the sessions. So I'll go ahead and put that in there, but that is a fun commercial. I have used it a couple times. All right. Well, take care, everyone. Have a good rest of your day. Thank you for coming.